So as we continue, I just want you to note that conditional statements are going to not necessarily always follow the same pattern, okay? So let's look at being able to identify some. If you purchase a computer and do not like it, then you can return it in 30 days. So let's use our highlighter here. So you see the word if, right there. Okay, let's not use highlighters. That was a terrible idea. Okay, so if, so then this is going to be P, right there. Then you can return it, it's going to be our Q, okay? So P is you purchase a computer and do not like it. Q is then you can return it within 30 days, okay? So that's the idea on this, okay? Whoops. That I have to actually click off the tool, okay. Okay, hypothesis. You purchase a computer and do not like it. Conclusion, you can return it within 30 days. Okay, identify the hypothesis and x plus 8 equals 15, then x equals 7. Remember, look at the key markers. So if and then. So if is our hypothesis. If x plus 8 equals 15, then x equals 7. Hypothesis, x plus 8 equals 15. Conclusion, x equals 7. If then statements might not always follow the same written if then form. Okay, not all conditional statements are written in if then form, but every conditional statement can be written in this form. So you can rewrite it to write it that way. Okay, hiking will be easier if you have hiking boots. Okay, so you notice here, if is second. So then this is actually going to be our P. This is going to be our Q. Okay. So if we rewrite this, we're going to see that if you have hiking boots, then hiking will be easy. So if was here, if you have hiking boots, then hiking will be easy. Okay. All squares have 4 sides of equal length. Now this one doesn't look, there's no if, right? So you're going to actually have to interpret it a little bit. So if a shape is a square, then it will have 4 sides equal. So actually, the if is kind of implied right here. If it's a square right here, then then it will have 4 sides equal length. So if it's square, the shape is a square, then it will have 4 sides equal length. Okay, so it doesn't necessarily have it always with if statements. Okay. Okay, let's determine the truth value of conditional statements. True when P and Q are both true. So if then statements, conditional statements, are true when P and Q are both true. Okay, they're true when P is false, and they're false when P is true but Q is false. Okay, so let's look at our helpful board here. So okay, that's fine. We can have all of it up. Okay, so you see our conditional statement, our board right here. P and Q, and let's actually have P implies Q right here. So conditional statements are going to be true if P is true and Q is true. They're going to be false when P is true and Q is false. They're going to be true when P is false and Q is true. They're going to be true basically whenever P is false. So conditional statements are true when P is true, and false if P is true and Q is false. So this is actually going to be an if-then statement right here. Notice it's going to be connected somehow with this false right here. So actually, if we made a truth table for not P or Q, what would we get? What would our truth table be? Okay, not P or Q. Well, not P would be true here and true here, right? Or Q would be true here, and this would be false, only false. Are these two truth tables identical? Yes. They are both identical, then actually these two statements are called equivalent or logically equivalent, okay? Now, you don't need to know how to spell that, but it's right there, equivalent, okay? Okay, so we're going to go back to the notes. Sorry, it takes me a second to transfer, okay, transition. So, if A and B are negative, then A plus B is also negative. If the moon has purple spots, then it is June. Okay, so let's ask a question. Which statements would be logically true? Not necessarily like useful, but would they be true? So if A and B are negative, A plus B is also negative. Well, P implies Q. So if A and B are negative, if that's true, then the conclusion Q is also true. So if we use our pen right here, right, this is P is going to be true. This is true. This Q will also be true, which means this whole statement is going to be true. Okay? If they're both negative, then A plus B is going to be negative. Okay? That's true, and that's true. If this is false, right here, if A and B are positive, then this doesn't actually matter. The truth value of this wouldn't matter. Okay, so then we can kind of ignore this right here. Scroll it out. Okay, the moon has purple spots. Well, that is gonna be a big old false. Then it is June. Does this even matter? Does this matter? No. So if our premise is false, it doesn't matter about our conclusion. The statement is going to be a true statement. That is because this is called a vacuous proof. Okay, vacuous. I will not spell this properly. Don't worry. Vacuous. Yeah, I think there's two C's. Whatever. This is why you don't spell on these things, because look how beautiful that is. Oh, I love the eraser. Okay. If you divide an integer by another integer, okay, so that's our premise. So premise, if you divide by another integer, then the result is also an integer. So if our premise is you're dividing by an integer, if it's a true statement, you're dividing by, the results will also be an integer. Is that a true statement? Well, I can provide at least one kind of example, so I would say this is a false statement. Example, what if you divide 1 by 2? Is that an integer? No. This is not an integer, okay? So that doesn't work. What if our premise is false? Well, in this case, if you do not divide an integer by another integer, if you divide it by something else, you have no idea what the result is. So this statement is going to be false because when the premise is true, i.e. when this premise is true, this doesn't work. So this one is true because the premise is always false, okay? This is always false. Always. But there's a possibility when this happens, okay? Okay? True, true, false. Okay? Write the converse, inverse, contrapositive. So converse is if Q then P. This is what we were talking about, how conditional and converse are not the same. Remember when you were doing the problems in 2.3, they had converse and conditional, and they're not the same. Yes, that's because if P then Q is this beautiful P arrow Q, and if Q then P, okay, inverse, yeah, inverse and converse are related logically, and contrapositive and conditional are related logically. Okay, you want to write these out. These are related conditions, write them out. Okay, let's go into some examples. If a figure is a triangle, then it has three sides. Write the converse, the inverse, and contrapositive. Okay, let me help you with this one. So converse, if a figure has three sides, then it is a triangle. So that's converse. Inverse, if a figure is not a triangle, then it does not have three sides. That's inverse. Contrapositive is, if a figure does not have three sides, it is not a triangle. There we go. Are these all true statements? Yes. A figure has three sides, it is a triangle. If it is not a triangle, it does not have three sides. If a figure does not have three sides, it is not a triangle. All those statements are true statements. Okay? We will come back to this we'll continue with this video in